For section 3.4, applications involving percents, what we're going to want to do is, there's a couple different approaches you could take with this, but what I'm going to use mostly is what you see right here, which is the percent formula, the percent equation, So the percent equation is where you do the percent, okay? And let's kind of break this down so you know what we're dealing with here, because we're going to deal with a lot of percent problems with this particular section. And for the percent, it's going to be important that you convert that number to a decimal. Oops, obviously, I can't spell. Convert to a decimal. So, for example, 17% equals 0.17, So just move the decimal over two places to the left. Do that. Then you're going to multiply that by the base, and now the base is another name for the whole. Okay, so, and sometimes it's not so obvious what the whole is, because the whole can kind of take different meanings, like what is the whole? Well, the whole could be, your total weight, your whole could be all the recommended calories. It's not always going to say, hey, this is the whole. You need to figure out what that is. Sometimes the whole is going to be like the original price. What was the cost of the shirt without tax or without the discount? So sometimes another way to think of it is like the original. All right, and then the part is pretty self-explanatory. That's it's going to be what we're looking for. The percent times base is going to equal the part, so it's going to be a fraction of whatever the whole is. Okay. All right, so let's go ahead and jump into our first one. It says use multiplication to find 30% of 150. Okay, so we got this. So 30%. So we're going to do. It's going to write this down. Doesn't hurt. Percent times base equals part. So 30% is 0.3. If you want to put a 0 there, you can. Multiply that by the base, which is 150. And then we're going to make that equal to n. Now, the reason I know that the base is 150, the whole is 150, and it's a little gimmicky, but it does work, is the word of. You see that word of there? That word of is a good indicator that we're dealing with the whole. Okay, of also means times in some context, but look for that word of, and whatever number is by it, you're probably on the right path there to figuring out what the whole is. Okay, so that of is going to kind of lead you in the direction of where the whole is. Okay, so you're going to do that, and then just do 0.3 times 150. 0.3 times 150. And that's 45. And we're not looking for a percent on this one, so you don't need to, just because it's a percent problem doesn't mean we need to tack on a percent. It's just 45. Okay, that's it. That's all we're looking for. We were looking for the part. You know how you know if it's a percent problem? It will say what percent. Find the percent. What percent of such and such number is this? You'll use that kind of phrasing. So look for that word, those kind of words, like what percent. Number 2, use an equation to find 30% of 150. Again, this is basically the same problem. So that's going to be 30%, 0.3 of times 150. And we don't need to do the math again. We know that that's 45. Write an equation and solve. 49 is, now another thing here is means equals. That's a good indicator that we're dealing with equals. So we have 49 equals, okay, 28%, change that to a decimal, of what number? So we don't know what the number is, so we'll just do n times n. And now just divide by 28 hundredths. So you're going to do that. And I'm using my calculator. Now I know in class I showed you how to do this the long way, but I'm just going to try to save some time here and just use my calculator. And then that comes out to 175. Not 175%, just 175. So for that one, we were looking for the whole, so 28% of 175. That seems to make sense. 28% is like a fourth, and 49 is like 50. So yeah, I mean, that doesn't seem too far off. All right, for number 4, it says, now this is the first one where it says what percent. We don't know what the percent is. So we're going to do 59.5 means equals. What percent means n? Don't know what that is. Of 70. So I'm going to write it like this, 70n, because multiplication, when you're multiplying, order doesn't matter. And when we solve this, we're looking for the percent. So we're going to divide by 70. And you're going to do 59.5 divided by 70. And then when you do this, you get a decimal. Now, when it's a percent problem that is looking for the percent, you need to make sure you convert it back into a percent. Now, that's a decimal. That's a decimal. So we want to convert back into a percent. And how do we do that? Well, we just have to move the decimal 2 places to the right. 2 places to the right. So this is going to equal 85%. And that's it. So it was our first problem there where we actually got a percent for our answer. All right, for number 5, says Yuri earns $2,400 a month, wants to put 5% in his bank account to save for a new car. How much does he save each month? How much of his paycheck remains each month? So a couple different things we want to do here. But let's just do this. So percent. So the percent is 5%. So I'm going to do 0.05 because that's what we're doing. We're doing percent times base equals part. Percent times base equals part. So 0.5% times, and the base here is 2,400, which is going to be the whole paycheck. And that's going to equal the part. So 5%, 0.05 times 2,400, which I think is 120. Let's see if I guess is right. It is. Okay. So that's 120. All right. So $120 a month. Not a ton. That's going to take quite a long time there. But I mean, if this person is saving for several years, yeah, they're going to have a pretty good sum of money left. Oops, sorry. It's 120 a month. And then if we want to figure out how much is left in his paycheck, you just have to subtract. That's it. So 0 minus 0 is that. Got to borrow, and then that's 8. And then 23 minus 1 is 22. And that's what remains. Okay, number 6. The Natsuki family is driving to the Outer Banks for their family reunion, vacation, I should say. And they already have driven 310 miles. All right, so Mrs. Natsuki has calculated that they have completed approximately 75% of their trip, and then find the total distance from their home to the Outer Banks. Round the answer to the nearest mile. So probably it's going to involve some rounding on this one. All right, so this one, they've already gone. Let's say we got percent. So for this one, the percent is 75%. All right, and then the base represents the total distance from their home to the Outer Banks, which we don't know. We don't know what that is, but we do know that it's some number plus 310, right? That's what it's going to be. And the part is going to be 310. All right, so let me just kind of start this again. So it's going to be 75% times the base is going to equal the part. I got that. Now at this point, it's a two-step equation. I'm going to subtract 232.5 from both sides. You get 77.5, right? 77.5 divide by 3/4 or by 75 hundredths. And when I do this, my calculator says 103.3333 repeating forever and ever. So this problem originally said or stated round to the nearest pole, nearest mile. So that's 103 miles rounded. For number 7, got Jim bought a digital camera on sale for $104, and the original price was $130. What percent of the original price did Jim save? So we're just going to do this. So 104. 104 is the part. Okay, 130 is the base or the whole, because that's the original price. And so on this problem, we're looking for the percent. So percent times base is the same thing as base times percent. So I'm going to do 130 times B. Oops, sorry, that's not what I want to do. I'm going to do 130 times N. How about that? Equals 104. 104, and then we're going to divide both sides by 130. Divide by 130. And when you do that, 104 divided by 130 comes out to be 0.8. And then convert that back into a percent. And you do that by moving the decimal over 2 places to the right. So number 7 is 80%. All right, moving on to the next page of your notes here, we've got steps for solving applications involving percent change, or percent of change is another way to put it. And what I did was I went ahead and put down the equations there that you want to use for percent of change. Now there's only 2 types of change that we can have with percents. They can either, well, I mean, there's 3, I guess, but one of them doesn't really count because no change means it didn't change. But it can either go down, percent of decrease, like right here, which is going to be the base times 1 minus the percent. Okay, 1 minus the percent, or 1.0. And sometimes people put like 1.00 there. And then minus percent equals the part. That's a percent of decrease. And, those kind of problems, that's going to relate to, I don't know, that's going to be like mostly like for discounts, if we're talking about a discount of some sort, or just something lowered, like your weight went down or the temperature went down. So something, decreased. So we're just talking about a general decrease there. And then percent of increase, you guys can write this down, is basically the same equation, except it's plus, okay? So it's gonna be the base and then times, in parentheses, 1 plus the percent. And that's gonna equal the part. And then here's the other thing too, I wanna also make sure that this is clear. For the base, and I know I stated this before, but for the base, we want to understand that the base represents the whole, and the whole is the original amount. It's the original price. So thinking of it like a sale or a discount or increase or whatever it is, it's what was it before? What was it before it was taxed? What's the price before it was marked up? Before the store wanted to make a profit on it. What was it before the discount? What was it before the commission? What was it before the original amount is what the base is going to represent, the original price, okay, the original weight, the original whatever, original anything. All right, and then so those are your equations. So you guys can pause the video, of course, and write those down. You're going to find that those are pretty helpful for figuring out percent of change. Okay, and make sure you identify that you know what kind of change it is. Okay, so for number 8, it's talking about shoes that were marked down. So this is going to be percent of decrease. We're going to use percent of decrease. So we're going to use all right, so for this one, the shoes were normally $80. So that sounds like an original number. That sounds like the base. So that's gonna be 80 minus 20%. So make sure, remember, whenever you're putting these things into an equation, you're changing them as, if we're using the equation part, we're changing the percents into a decimal or a fraction. Decimals are much easier though, aren't they? They are. And then that's going to equal the part. So it's going to do 80, and then 1 minus 0.20 is 0.80 or 0.8. And 80 times 0.8 is going to be 64. And that's what the price of, that's what the price is going to be after the sale. Okay, so the shoes are going to be $64 after the 20% markdown. All right, number 9, the sale price of a digital camera is $104 after a 20% discount. Same thing. We're going to do this problem using the same kind of equation. Different numbers. I mean, not that different really. But we're going to do 104. 104 is going to represent the base. This is the discount, so we're going to do minus 20%. And that's going to equal part. Now, I really haven't said much about the part, but the part, in a lot of these problems, the part is going to be kind of like, how there's a cause, every cause there's an effect, right? So the part is going to be, what is the price after the discount? What is the cost of the meal after tax has been added on? What is the price after something has been marked up? So it's after. Okay, and a lot of times sometimes it'll be a much smaller number, sometimes it'll be a bigger number. So sometimes that throws people off because sometimes we think, well, the base has to be bigger, and that's not necessarily true. The base just has to represent the whole, which represents the original number. Okay, so remember, things can go, percents don't have to go one direction, they can go up or down. So we've got 104 times 0.80, and so if we do that, you're going to get 83.2. Make sure I did this right. Did. Okay, and so now we've got $83.20. So that is going to be the sale price. Oh, shoot. I just did that wrong. I just realized it. See, it's good. It's good for me to good for you to see sometimes me doing things wrong. Because I didn't read through the problem. That's usually my problem. Going too fast. But I just realized this says the sale price of a digital camera is 104. So 104 is the after. I was just explaining that and I didn't even do that. So that's me for you. And then, all right, so we don't know what the base is. Don't know what the base is. So we're going to make the B is going to be the unknown. And then 104 is going to represent the part. And then 1 minus 0.20 is the same number we got before. We're just doing a different thing here. And we're going to divide by 8/10. 8/10 right there. All right, so we're going to do 104 divided by 8/10. And the reason I caught my mistake, which I think is good for you guys to sometimes see that I'm not perfect and nobody's perfect when they do these, but it's also the reason I spotted my mistake was because I'm always thinking about when I do a percent problem, whether my answer makes sense. You know, does that seem to work common sense wise with the numbers that were given? And what made me think twice about this was it says the sale price of the digital camera. So the sale price, which tells me that the original price is going to be more, not less, not less. So that's why I was like, that doesn't seem right. So then I realized I didn't read it carefully enough. That was it. All right, so it's $130. All right, so for number 10, the cost of a home increased $225,000 from the original purchase price. If this increase was 12.5, what was the original purchase price? So just like on the last problem, we're going to do the same thing. We don't know what the base is. And this is a percent of increase. I mean, it literally uses the word increase right there. So it increased 12.5%. So I'm going to move over the decimal 2 places. 1, 2. And then we're going to make that equal to the price it is now, you know, the after, you know, the B, sometimes people say, well, the B represents the before, you know. So we're going to do this. We're going to do what is going to be 1.125B equals 225,000. And now we just have to divide by 225,000. I mean, divide 225,000 and divide that by 1.125. And I got a nice clean number. And I got 200,000 exactly, right on the nose. All right, the price of a waffle iron is $15.60 after the discount. So this after is telling you that's the part. All right, this is the discount, so this is telling you that it's a decrease. So we're going to do the base. We don't know what it is. All right, and we're going to do 1 minus 35%. And then make that equal to the after price. You know, what was it after the discount? And then 1 minus 0.35 is 0.65. And just divide by 0.65. And then it's $24. There it is. I gotta apologize. I know this is kind of a long section. There's a lot of examples here we have to go through, but it doesn't hurt. There's a lot 2%. You really do want to practice it and make sure you're getting it right. All right, now this section right here, we talk about the simple interest formula, simple interest. All right, now the simple interest formula is right here, actually. Principal PRT, principal times rate times time equals interest. That's the simple interest formula. All right, now it's good before you actually know that you're using the principal, the simple interest formula, that you know what all those things represent. So the principal represents how much money is borrowed or invested. It depends. Now, interest, if you're wondering, interest is like a fee, right? It's most of the time we're paying the fee. We're the one paying the interest on the credit card or on a mortgage or on the car loan or whatever. We're the one paying the interest. Very few times do we actually earn interest unless it's something we're investing. But we're putting money into savings account. That's the principal. But yeah, the principal is, if we're thinking about a loan, the principal is how much money you need. Okay, it's exactly what you need. So you need $500,000 for a house. That's the principal, 500,000. We're not talking about taxes. We're not talking about property taxes either. We're not talking about where you have to pay the realtor and all that kind of stuff. It's just, that's what it is for the house. You need $500,000. That's it. All right. It's also how much you invest. So you have so much money you want to put into an account. You have $1 million because you're rich and you're like, oh man, I just need to save this money. Then that's your principal. But your principal is kind of what you're starting off with. All right. The rate is the percent. Okay. The rate is the percent. So sometimes this formula throws people off because they think P stands for percent. P stands for principal. All right. So the rate, R, is what you're being charged. Okay. So you have good credit. You go get a car loan. They charge you like 3%, 4%. Depends on what interest rates are too at the time. All right. You have a credit card and you're late a bunch of times and they're penalizing you. And so you're paying a high rate. So like 20, 25, 30%. Some obnoxious amount. All right. And then T stands for time. That's time. So number of years. Oh, by the way, let me go back for a second. Make sure for percents, which we have been doing, but make sure you convert to a decimal. So you can convert that to a decimal. Time represents the number of years. So if it's a house, typically a home mortgage is going to be 15 years to 30 years. That's what it's going to be. If it's a car loan, it could be 3, 4, 5 years, 6 years, 7 years. I've heard some people getting 8 years. That would be a bad idea just because of all the interest you're paying. So the shorter the time that your loan is for, I know sometimes the higher the payment, but the less interest you're paying overall because you're not spreading it out over such a long period of time. So for number 12, let's go ahead and do this. $400 is invested for 1 year in an account earning 5% interest. So how much interest will be earned? So this one's pretty straightforward. We've got $400 is the principal, $400. We're going to multiply that by the rate. Now the rate says 5%. So 0.05, and then times that by the number of years. And just so you know, for number of years, it's got to be years. So sometimes when you're doing an interest problem, it doesn't always give you years. Sometimes it gives you months. It might just say 6 months. All right, but we can't use 6 because if we put 6 into that equation, then your interest formula doesn't know what you're doing. It just thinks you're going to be doing 6 years. So that wouldn't work. So you got to convert 6 months into years. 6 months into years is 0.5 or 1/2. So you got to do that, or 18 months perhaps. 18 months would be 1.5. 9 months is 3/4 of a year, which would be 0.75. So you just got to make sure you convert. If it's not exactly years, make sure you do that. Make sure you convert those numbers into years. All right, and now for this one, we're just going to do this. And so what our answer will be the interest. So we're going to do $400 times 0.05, which comes out to be 20. So $20. So that's what your bank, your money just sitting there in the bank is going to earn $20. All right, for number 13, Ramon invests $1,500 in an account earning 3% simple interest. And then Ramon has another account with $4,000 earning 4.5% interest. So after 1 year, how much interest will he have earned? So we want to basically do two simple interest problems here together. So that is what we're going to do. So we're going to do $1,500 times the rate times 1 plus the other account. So the other account is 4,000 principal, 4.5%, okay, times 1 year. Some of you might be thinking, like, what's the point of putting 1 there? You don't have to. I'm just putting that in there just so you can see principal, see the rate, and you can see the time, okay? And now we're going to do this. So work this out right here, 1,500 times 3%, that is going to be $1 million. Now it's going to be just, 1,500 times 0.03 is going to be 45. And then we're going to do 4,000 times 4.5%. So he gets, so Ramon is getting $45 on the 3% account. He's getting $180 on the 4.5% account because he has more money in there. And together, you just want to add those up. Add them up, and you get $225. All right, number 14. All right, Tika had $6,000 to invest. She invested some of it in the savings account and paid 3%, and the rest of it in a certificate of deposit, also known as a CD. Sometimes, whenever you drive by a bank, you sometimes see them advertising CDs. Banks love, for some reason, they love CDs. They love when people go in there and put money into CDs. I'm not sure why, but they do enjoy advertising those. All right, in 1 year, she earned a total of $285 interest. Now, that's total, that's for both accounts. It's for the $6,000 account, and it's for the other account that was 6%. So we don't want to guess and check our way through this. We want to use the algebra here, and that's what we're going to do. So we're going to do for this one, the principal is, well, here's the thing, we can't use 6,000. Can't use 6,000. So the principal is going to be, let's say the principal is N for one of the accounts, okay? It's going to be N for one of the accounts, and we'll call that principal 1. And the principal for the other account, principal 2, is going to be 6,000 minus N. So that's what you're going to do. You want to do, because we don't know what the principals are individually, but we do know that together they're going to be N and 6,000 minus N. So that's what we're going to do. So we're going to do principal N times, what is the percent on that one? 3%? 0.03 times 1. This is 1 year. Plus, get rid of the parentheses there, plus 3%, not 3%, 6%. So I'm going to multiply by 0.06. Then I'm going to multiply that by the principal. And then we're going to make that equal to the total interest for both accounts, $285. Just so you know, right here, that's the rate. And right here, that is the principal. And hopefully that doesn't throw you off, but principal times rate times time. I know I didn't put a times 1 in there. I didn't put it 1 year, but principal times rate is the same thing as rate times principal. When you change the order of a multiplication problem, you're not changing the order, or you're not going to change the product. And we're ready to do this. So we've got on this one, this is just going to kind of clean it up here for our first step. Distribute, and you're going to get 360 there minus 0.06n equals 285. And I'm going to put together like terms here. So 300s and minus 600s makes negative 300s. Plus 360 equals 285. Then we're going to subtract 360 from both sides. So you're going to do 285 minus 360, which is 75 or negative 75. Oh, I forgot an n on this one. Sorry. I forgot to put an n right there. There was an n there. Then just divide by 300s. So I got, when I did that, I got 2,500. So that's the principal. So 2,500 for that one. So one account has $2,500 in it. The 3% one does. And the 6% count is going to have 6,000 minus 2,500, right? Which is going to be 3,500. And that one is finished. Oops, I'm going to circle that. All right, that was kind of a tough one, I know. But, you know, working these through doesn't hurt because you're going to see these on Alex. Just kind of always go back to the notes and see what I did or see what you did when you wrote it all down and see if it makes sense. So I think that's it for that one. All right. All right, we're on mixture problems here. Let's do these. We never did these in class. So I'm going to do these right now with you as well and remind you on Blackboard that you probably need to look these over. All right. Sorry, this is a long video. Make sure you're just breaking these up. Don't feel like you have to watch it all at once. All right, so for the mixture problems, what do we have? We've got, what do we have? I want to make sure my notes that are covered. All right, so I have the steps for solving a mixture problem like this is going to be like setting up a table. Not that you have to set up a table, but a table does kind of organize everything kind of nicely. So I have this table already set up for you. So right here, we're going to label the percent of acid in the solution, and we're going to write that as a decimal. The second column is going to represent liters of the solution. And the third column is going to be the liters of acid, which is going to be basically the product. You're going to multiply for that one. You're going to multiply, we'll call this A, we'll call this B. You're basically going to multiply A times B. And that will be the liters of acid. Okay. So on this first example right here, we've got a chemist needs to make 15 liters of a 5% acid solution. All right, she will make it from different parts. So she's going to make it from 3% acid solution and some 9% acid solution. How much of the 3% solution and the 9% solution should she use? So we're going to figure this out. We're going to put all these numbers in. So we've got on this one, we've got 3%, so 0.03 right there. And on the other one, we have 9%. We have 9%. And those two right there, let me just kind of stop for a second here. Those two right there are going to be mixed. That's the part we're going to mix. Okay, and then when we're all done with that, we want to get, what does it say? It says 5%. Now I know, like, thinking of this may not look like it makes any sense because 3 and 9 doesn't make 5, right? 3 and 9 makes 12. But that's not the point, because we're going to put certain amounts of each mixture together, and when we're all done with it, it's going to end up with 5% mixture. Okay. And then the liters of the solution is going to be, what do we got there? We've got 15 liters of a 5% solution, and she'll make it from 3% acid. So what are we going to do? We're going to do, for this one, we're going to do, how about X? Okay. And then for this one, I'm going to do -15 X. And then for this one, we're going to do X, because that's what we need. We need a 15%. And then we're going to multiply those things. So multiply them out. So this one comes out to that, 0.03x. And the other one is going to be 0.09 times 15 minus x. Let's go ahead and just do that now. So you got, that's going to be 1.35. And for this one, we're going to do 0.05 times 15. And there's the numbers that we kind of have to worry about. Some of them are expressions, actually, but that's what we're going to do. All right, so that's how we set up the table for that one. And now we want to put all this together. So that is what we're going to do. So we're going to do the 3% mixture plus the 9% mixture is going to equal the total mixture. See what I did there? And then we're going to solve this. So those are like terms. Oh man, so sorry about that. So I'm just solving the equation right now. Sorry if I'm being quiet, and that's what I got so far. All right, so now there's one more step, which is to divide. These are almost the same. It's a little bit different. And then that equals 10. So X equals 10 liters, right? So right there, you're going to put, that's 10 liters. And the other one's going to be 15 minus 10, which is 5. So 10 and 5 makes 15. And we're done with that mixture problem. All right. All right, number 16. How many liters of a 70% alcohol solution must be added to 50 liters of a 40% alcohol solution to produce a 50% alcohol solution? Oh my God, that sounds confusing, but let's just kind of go start from the top here. We got 70%. Okay, 70%, and we don't know how many liters that is. So I'm gonna put N there. We'll put N, and then we have 40% solution. Let's just read through this. And this one we don't, must be added to 50 liter. Oh, that's just going to be 50. So now just multiply those. And, oh, and by the way, we're looking to make a 50% solution. Right there. We got that, and that's going to be N plus 50. All right. Sorry about being quiet here again, but just kind of working these through. So the liters of alcohol, we got 0.70 N because we multiply those, 0.7 times N. And then this one was just plain 20. And this one was more of an expression, 1/2 N plus 25, 0.5 N. And just like we have been doing, we're just going to put it all together. And let's subtract both sides. And that side is going to equal 5. And now it's just a matter of dividing both sides by 2/10, 0.2. Let's cancel, and all you're left with is n. And then you're going to do 5 divided by 0.2, which is 25. So that's 25 liters right there. And that's it. That's all you have to do on that one. All right. Sorry about that. This lesson was extremely long for a YouTube video. I get it. But again, just pace yourself through these notes. Try not to feel like you have to sit down all at once and do it. But yeah, this was a lot of notes. Got it. I'll see you in the next lesson.